Good morning, students. This is another periodic property of elements, electron gain enthalpy. In last class we have done ionization enthalpy, and this is electron gain enthalpy, which is represented by the symbol delta Hg. Now what is electron gain enthalpy? It is the energy released when a neutral gaseous isolated atom gain an extra electron to form an ion. Suppose this is one of the neutral element and this is in the gaseous state. When it gains one electron, then it produces the anion X minus, and after production of X minus anion, it releases one energy, and this energy is called electron gain enthalpy. I mean, after gain the electron, how much energy is released, that is called electron gain enthalpy. The difference between electron gain enthalpy and ionization enthalpy is, in ionization enthalpy energy is required, I mean energy you have to supply, but here no need to supply the energy. Instead of supplying, energy will be released. And always you have to know one thing, releasing energy always represented by negative sign. Like exothermic reaction, in exothermic reaction energy is released, heat energy is released, that's why heat is represented by negative sign. Similarly, here also energy is released, that's why electron gain enthalpy always represented by a negative sign. Negative sign means it do not represent the decreasing amount of energy. Negative sign represent it released energy, and positive sign represent required energy. Ionization enthalpy always represent by positive sign because it is required energy, and here energy is released, that's why it is represented by negative sign. So X is one of the atom, it is in the gaseous state neutral atom. Suppose its electronic configuration is 2,7. When it gain one extra electron, after gaining the electron configuration becomes 2,8 and it becomes stable, and due to stable formation it releases some amount of energy. That energy is called electron gain enthalpy, and since the energy is released, that's why it is represented by negative sign. Now like ionization enthalpy, electron gain enthalpy always also you will get as successive electron gain enthalpy. Successive electron gain enthalpy means, suppose one atom have the electronic configuration like this 285. To make it stable, it should gain 3 electron, and these 3 electron, when the atom gain, it gain the electron one by one, not as 3 electron togetherly. So first time it will gain 1 electron, then it becomes X minus, and it releases one energy which is represented by delta Hg1, I mean first electron gain enthalpy. Similarly, this X minus, whose configuration is 2H6, again it gain 1 extra electron and it becomes X2 minus, again it release one energy which is called second electron gain enthalpy. Similarly, X2 minus again gain 1 electron, it produce X3 minus, and it will release one energy that is called Eg3, third electron gain enthalpy. This first electron gain enthalpy, second electron gain enthalpy, third electron gain enthalpy, these are commonly called successive electron gain enthalpy. So in ionization enthalpy you have to remove the electron, and here electron gain enthalpy, in electron gain enthalpy you have to gain the electron, and that's why it is called electron gain enthalpy. Ionization enthalpy is the required energy, but electron enthalpy is the releasing energy, and that is why it is represented by negative sign. Now, what are the factors affecting electron gain enthalpy? I mean, for what type of atom electron gain enthalpy value will be high, for what type of atom electron gain enthalpy value will be low. So the factors affecting electron gain enthalpy. So the main factors I will give you which can affect the electron gain enthalpy value. Number 1, atomic size. electron gain enthalpy will be high or low. It mainly depends on the size of the atom. For example, this is one atom. This is the nucleus, first cell, second cell. I mean, it contains two cells. And this is one of the atom, first cell, second cell, third cell. And this is suppose fourth cell. Since the cell number is more, the size of the atom is larger. Here cell number is less, that's why size less. So when you gain an extra electron, here you will enter the electron in the valence cell, I mean second cell, and here you will enter the electron in the fourth cell, since fourth cell is the valence cell. Now here nucleus is closer due to smaller size. Here nucleus is far away from the valence cell due to larger in size. Since the nucleus is far away from the valence cell, that is why the incoming electron cannot be attracted by the nucleus strongly. But here due to small size, due to closer in nucleus, the nucleus can attract the electron more. That is why here the atom, due to small size, it can gain the electron more easily as compared to this one, because force of attraction with the nucleus is more. And for this type of atom, since it can gain the electron energy, since it can gain the electron easily, that is why it releases more amount of energy as compared to this. I mean, as the size of the atom increases, electron gain enthalpy value decreases. Due to smaller size, nucleus can attract the electron more, and that's why energy release will be more. So that is why to gain more amount of energy, size of the atom should be small. So this is one of the factor. Another factor number 2, nuclear surge. Nuclear surge. The electron gain enthalpy value, it depends on the surge of the nucleus. Surge of the nucleus means surge of proton, which is also called nuclear surge. If the proton surge is more, I mean if the positive surge is more, attraction will be more. If the proton number is less, attraction will be less. So as the nuclear surge increases, suppose there are two atoms which contain two cells like this. This one contains two cells, this one also contains two cells. So both the electron will enter in the second cell. But let here proton number is more, here proton number is less. And due to less number of proton, attraction will be less. Here due to more number of proton, attraction will be more. And that is why it will release more amount of energy. I mean, as the nuclear surge increases, as the proton number increases, force of attraction with the electron increases, and that is why it will release more amount of energy. So nuclear surge, I mean surge of proton, is one of the factors which can affect electron gain enthalpy. And number 3, which is called electronic configuration. The electron gain enthalpy value depends on the electronic configuration also. The elements which contain completely filled orbital, the elements which contain half filled orbitals in their electronic configuration, that type of configurations are said to be stable, and for that type of atom it is difficult to gain the electron, and that is why for that type of atom ionization enthalpy always decreases. I mean those elements which contain half filled or completely filled orbitals, they have some extra stability, and due to stable nature it has no tendency to gain the electron, and that is why for that type of atom electron gain enthalpy value always will be less. For example, beryllium, its configuration is 1s2 2s2, both are filled up, and due to filled up configuration it has no tendency to gain the electron, and that is why for that type of atom the energy release will be very less. So mainly it depends on 3 factors: atomic size, nuclear surge, and electronic configuration. That is why when you get 3 or 4 elements and if you want to arrange them in order of increasing electron gain enthalpy, so you follow these 3 factors. You see their sizes. If the size is small, electron gain enthalpy will be more. You see the nuclear surge. If the nuclear surge is more, all the factors you have to combine. Also you have to check the electronic configuration. If the electronic configuration is stable, for that type of atom electron gain enthalpy will be less. So by applying these 3 factors, you can arrange the elements which one have more electron gain enthalpy, which one have less electron gain enthalpy. Thank you.